Hello everyone, this is Vaishnavi Dadmure along with Smarnika Bisoi. We are interns at Emertxe Technologies. During our internship, we have built a home automation project based on IoT. Today, I am going to give a presentation on our project which is IoT based on home automation. So, let's begin. This is the scope of our project and these are the contents of it. During our internship, we studied following topics, which included C and C++ programming, IoT, and embedded systems. In C programming, we studied keywords, basic data types, operators, conditional structures and looping concept, arrays, pointer functions, storage classes, and header files. In C++, we studied some basic OOP concepts. We studied about IoT, introduction to IoT, introduction to embedded systems, and peripherals. These are the peripherals required for our project. Now, what is peripheral? Peripheral is an internal or external device that connects directly to the computer. These were required in our project. We have used LDR sensor, temperature system, serial tank. Now let's see what is IoT. IoT, Internet of Things, simply describes physical objects that contain embedded technology. This is the architecture of IoT. Now, what is embedded system? An embedded system is a combination of computer hardware and software designed for a specific function. This is the architecture of embedded system. These are the project requirements. Control garden lights on basis of sunlight intensity, temperature system control, water tank control. These are the components required for the project. In hardware, we have used Arduino Uno, ETH W5500, PSF8574, temperature sensor, LCD, LDR sensor, and LED. In software, we have used Arduino IDE, which is used for coding, PicSimLab used for simulation, Null Modem emulator to configure ports of serial remote tank, and Blink IoT app. It is a mobile app which controls the operations. Now, Arduino Uno. Arduino Uno is an open source microcontroller board based on Atmega 328P. This is how it looks. ETH W5500 is a Ethernet. It is a hardwired TCP/IP embedded Ethernet controller that provides internet connection to embedded system. Here is the Ethernet server. PCF8574. It is a silicon CMOS circuit. It is a 8-bit input-output expander. Temperature sensor. It is an electronic device that measures temperature. LCD. Liquid crystal display controller which displays alphanumeric and symbols. LDR sensor. It is light dependent resistor. And here is the picture of it. Now, here comes the implementation. These are the output screenshot. This is the first step when we load the hex file. Here is the LED on-off pictures. When LDR is high, LED is on. When LDR is low, LED is off. Here comes the cooler pictures when cooler is on and off. These are the heater pictures where heater is on and off. This is inlet valve when it is on, inlet valve when it is off, outlet valve when it is on, outlet valve when it is off. These are the mobile screenshots from Blink IoT app. This is the notification of heater temperature. This is when heater automatically turn off when temperature rises above 35. This is notification of water level. This is water tank. This is when water tank is full, inlet valve will automatically turn off. Water volume level. And here comes the conclusion. Thank you. Now simulation and code will be explained by my teammate Smarnika Bisui. So I hand over this to her.
Hello everyone, my name is Marnika Bisoi. Now I will explain you the code for this home automation project. First of all, we are including all the required header files and libraries into it. Then we are writing our authentication code, which is of Blink Cloud. Then we are initializing the variables, declaring it, and we are including the libraries that is required. Then we will mention different functions and their definitions into it. So this cooler weapon function defines, it gives us the control to control the cooler by clicking it on and off using our mobile apps, and the LCD will display the cooler is on and cooler is off. Similarly, when it comes to heater weapon, this will take the input and then it will also display when the heater is on, it will show on, and when heater is off, it will show off on the LCD screen. The inlet weapon will display the inlet flow of water tank. So it will again enable the inlet, and it will show that the cursor on the LCD screen whether the flow is on or off, and it will take parameters. It will read the values from the Blink app. Similarly, for output pin, it will again show whether the flow is on or off on the LCD screen, and these methods are called enable outlet and disable outlet. Update the temperature reading will be helpful for us to give the values to IoT app. So basically the app will show the display of the temperature as the temperature is moving. Even the water value will be displayed on the mobile app. When it comes to handle temperature, this will check if the temperature is greater than 35 degrees, then the heater will turn off and then it will print as the heater is turned off. And similarly, a notification window will appear on the mobile IoT app where it displays that the heater will be off because the temperature is exceeding 35 degrees Celsius. When it comes to the function of handle tank, this will mention that if the tank volume is less than 2000 and the inlet valve is closed, at that moment it will turn on the inlet valve and it will show that the flow is on, and the notification will be printed on the mobile app that water level is less than 2000, so the flow will be on. Similarly, if there is the volume of 3000 and if the inlet valve is open, at that moment it will disable the valve. That means the flow will be stopped and it will be mentioned on the LCD that the flow is stopped. Simultaneously on the notification window of the app, it will be mentioned that water level is full, so flow is stopped. In the setup, we will always initialize, will always declare the init methods, and in the loop we'll always call the method that is already declared. In ldr.cpp, in this file we are declaring the brightness control method, which means this method will declare that the blinking of LED with the help of LDR. In ldr.h, it is the header file where we have declared the macros, LDR sensor, and we have given it as a value, and we have also defined the methods. In main.h, here also we have declared all the macros that we are using in the program. Serial tank.cpp will be declaring all the methods into it. In this volume method, it will declare the volume, how much volume is there in the tank and not. And the different methods like enable inlet will show that the inlet valve is enabled or not, disable inlet, and various methods are declared over here. In serial tank.h, that it is the header file that will mention all the macros in it, and the method names are declared over here. Temperature system.ccp will give us about the method's name, that cooler control. That means it will give digital write cooler dot control, which means that the values will be read by the system when the machine is on and off, and it will be passed and declared in the LCD. Similarly, when it comes to temperature, this will convert the temperature into degree Celsius. This method will be helpful for converting the temperature into degree Celsius, and it will declare all the method that is required for the temperature system. And the temperature.system.h, this is the header file where we are already declaring the method names and we are declaring all the macros. In this way, we'll be able to code our system, and once our code is ready, we'll compile it and we will upload the compiled code in the Arduino of Pixim Lab. Once the compilation is done, the hex file is ready. Here the compilation is done and our code does not have any error, so we can upload it on the Pixim Lab. Now let's look at the simulation part. So this home automation project consists of blinking of LED with the help of LDR. When we lower down the resistance, the light turns off, and when we increase the resistance, the light will turn on. Remaining part can be controlled by our mobile application. Here I have kept on the Blink app, where we can see the option of cooler. When we click on, the cooler starts to on, and over on the screen we'll see the cooler is on. When we click on the option off, the cooler will stop and it shows as the cooler turns off. When we click on the heater on, the temperature on the screen will increase, and when it turns above 35 degree, automatically the heater turns off. And here we get a pop-up message that temperature is above 35 degrees Celsius, turning off the heater. If we again turn it on, it will increase the temperature, but automatically again it will turn it off. And when we turn on the cooler, the temperature decreases, the fan also turns on, and here on the screen we'll also get the temperature is decreasing. Similarly, if we turn it off, it turns off. When we go to the second tab, which indicates the water level, we can see it with the help of the serial monitor, where we'll see this tank over here. So let's look at the tank. So this is the tank. If we keep the inlet on, the tank is filled. Once the tank gets filled, automatically the flow is stopped. When we turn on the outlet valve, the tank is decreasing. Here on the screen it shows outlet is on, and once it decreases below 2000, the inlet will get on. See, here the inlet is on. Again, when we stop the outlet, on the screen outlet is off, the inlet is full, and once it completes 3000 liters, automatically inlet will be off. Now the inlet is automatically off. We can turn on the outlet to check the water is decreasing. Here on the screen also it is decreasing, and on the tab 1 we can see a notification. The notification shows that the water level is less than 2000, so water inflow is enabled, and if the water level is full, the water inflow is disabled. In this way we are able to control the water level over here. So basically in this internship, we have completed a project that is based on IoT home automation, for which we have just now seen the simulation. So basically what this project does is, this project we are controlling from a Blink IoT app from our mobile phones, where we look that when we turn on the heater will start, it will show on the LCD screen. So heater turn off mechanism is controlled by this app. Then cooler turn on mechanism is controlled by this app. Then LED blinking using LDR is controlled by this app. Then temperature sensor is also controlled by the app, and the temperature is visible on the mobile screen. And water tank outflow and inflow of water is also controlled in this project, and the notification is sent to the IoT app. So basically we are able to see the notifications and the temperature changes and water level changes on the mobile phone on the app, and we are able to control it from the mobile, and we can see that on the laptop screen on this big SimLab simulator. So this project is made in a group of two people, and the names of the group members are Vaishnavi Dadmode and Swarnika Bisoi. Thank you.